I'm going to go through a bunch of proofs just to give you guys some examples to reference in case you're kind of hung up and then you just want to see some more of how proofs work and how they get written out. To start, I'm going to list all the things that we've learned up to this point that you're allowed to use in proofs. Okay, so the main one is definitions. Any definition, anything that's defined, okay, you can use in a proof. So any definition that we've learned, for example, we've learned the definition of congruence. Okay. Okay, the definition of congruence says that if AB equals, let's use CD. AB equals CD, then segment AB is congruent to segment CD. It also goes the other way. If AB is congruent to CD, then the length of AB is equal to the length of CD. Okay, so what this is saying, since it's biconditional, which all definitions are, if I meet a hypothesis, if I meet this hypothesis, so if I have two things that are equal, I can say that they are congruent, and my reason would be definition of congruence. I can go the other way too. If I have two things that are congruent, I can then say that they're equal by the definition of congruence. Okay. Another example, we use the definition of perpendicular, which states that two lines are perpendicular. This is an if and only if. If and only if they meet at a right angle. That means if I meet one of these conditions, so if I know, so let's say AB is perpendicular to CD. Okay, if I know that, if that's given to me, maybe that's a given, then I can say, well, I'd have to know which angle they meet at. Okay, if this is A, B, and this is C, B, they meet here at angle 1. I can say that angle 1 is a right angle. That's what the definition of perpendicular tells me. I could go the other way too. Let's say it's given that angle 1 is a right angle. Then I can say AB is perpendicular to CD, because that's the definition of perpendicular. Okay, because this is a biconditional statement, so if I meet either this part or this part, then it results in the other part being true. Okay, so you can use definitions that way in your proofs. Some of the things that we've already learned would be the segment addition postulate. Okay, so if I have a picture, if on my picture I can see that I have 3 collinear points and I have one that's in between the other two, I can write AB plus BC equals AC by the segment addition postulate. Okay. There's also the angle addition postulate. which is pretty much the same thing. A, B, C, D. If I can see that I have two adjacent angles, I can say that angle A, B, C, or the measure of angle A, B, C, plus the measure of angle C, B, D equals the measure of angle A, B, D. Okay, so however many degrees that is, okay, which would be this part, plus however many degrees this is, which would be this part, equals the total number of degrees, this part. Okay, and I'm allowed to say that because of the angle addition postulate. So if you're adding two adjacent angles up, it's the angle addition postulate. What else have we already learned? You can use the distance formula. You can use the midpoint formula. You know, if you need to find the length of something, you know, if they give you 2 points and they say, what's the length? You're allowed to use the distance formula and state your reason as distance formula. So if I have 0.15, use an easy one here, 49, I can say that I would get my distance formula here. So I do 4 minus 1, which is 3 squared, plus 9 minus 5, which is 4 squared. I get 9 plus 16, which is 25. Square root of that is 5. And I could say AB equals 5. Reason, distance formula. Okay, and any algebra properties that we've used, you know, on the previous lesson, you're allowed to use also. So these are just examples of things that you can use in your proofs. We're going to go through some proofs. These first ones I'm just going to start by, I've got some reasons here. I'm going to match these reasons to my statements. So, most problems are going to, I don't know how well this blue shows up on here. They're going to start with some given information. Okay, you usually want to list your given information first. Right? It's always a good idea to list it out there right away. That way you can always draw upon what you've listed already. So here I've written down what was given to me. So my reason I can say that is it was given. Next, I need to look at what changed from this first statement. What did I do to this statement to get here? What step did I take? Well, 15 went up to 45, which means it multiplied by 3. This side has also been multiplied by 3, so I multiplied an equal amount to both sides of an equation. That's the multiplication property of equality. Next, I multiplied this 3 inside here. The right side of my equation didn't change, so I know it's not some property of equality, but since I'm distributing, I've used the distributive property to get here. And then I would add 12 to both sides, and the addition property of equality is what allows me to get there. Here again, I'm given some information. So the first one is given information. And then I distributed the 6. So that would be the reason for this one. That's my justification. Then I subtracted 12 from both sides to get here. And then I divided both sides by 6 to get there. So just matching up some reasons. Here's my given information, so I'm not going to be able to build off of that. I'm going to be able to use it later. But this first statement says that the measure of AOB, which is this angle here, plus the measure of BOC, which is this one, equals this whole thing. I'm adding two angles together. That is the angle addition postulate. This next one, I've removed this, and in its place, x has moved in. Okay, so this is exactly what it seems like. I'm taking something out, putting something in its place. I'm substituting x in for measure of angle AOB. That's the substitution property. Okay, like the same thing, I'm substituting 3x plus 5 in the place of this. I'm substituting 145 in the place of this. That's all substitution property. The next one, like I talked about on the previous video, I haven't done anything to both sides of the equation. The only thing I did was I changed the left side of the equation to make it more simple. So I'm just going to write, my reason here would be simplify. I just simplified. Then I subtracted 5 from both sides. That's the subtraction property. Oops. Hitting the wrong buttons here. So I've subtracted from both sides to get there, and then I divided by 4 on both sides. So that would be my reason for that. Okay, on this one, what we can do is, I recognize this picture. Okay, we did this a lot in chapter 1. I've got two angles, and together they're making this straight line. So I know that that's called a linear pair. The linear pair, I know that this angle plus this angle is going to equal 180 degrees, which is exactly what I've written here. So I'm using the definition of a linear pair. Now the next statement, again, I took out the measure of AOB and I put in its place what it equals. So again, I'm substituting. I'm using the substitution property. Here, I'm combining like terms. So simplifying. I subtracted 10 from both sides. That's the subtraction property. And then I divided both sides. That's the division property of equality. Okay, I look at my picture. I can see that B is in between A and C. So I'm allowed to say that AB plus BC equals AC. Okay, this piece plus this piece equals the whole thing. That is the segment addition postulate. And then I'm substituting values in for segments. I'm simplifying. I'm adding 15 to both sides using the addition property of equality. And I'm dividing both sides by 5 using the division property of equality. This one's very similar. I see that y is in between x and z, so I can say this because of the segment addition postulate. Okay, so now we're kind of going to turn them more into, instead of just using arrows, I want more in the form of a proof. So the next thing I would say is, okay, what did I do to get this? I'm substituting values. Okay, substitution property, which is reason number 1. I'm substituting. The next step I took is I distributed. I distributed this 3 inside here to get my next statement. I'm using the distributive property. Then I simplified. Then I subtracted from both sides. Subtracted 18 from both sides. That's reason number 4 over there. And then I divided both sides. That's reason number 3 over there. Okay. Here, C is the midpoint of AE. I'm not getting that from my picture. Okay, if I look at my picture, in order for me to look at a picture and know that C would be the midpoint, I would have to know that these pieces are equal. I don't know that. So how do I know that C is the midpoint? It's because they tell me up here that C is the midpoint. This is given information. Once I know that C is the midpoint, when I hear the word midpoint, I know that it's right in the middle. Okay, it's the dead middle. It's creating 2 equal segments. So by the definition of the midpoint, I know that AC is equal to CE. Okay, I know these are the same. Then I'm substituting values in. Okay, AC, instead of AC, I can write 6x because they are the same thing. 6x is AC. Substituting. And I'm subtracting 3x from both sides. And I'm dividing both sides by 3. Okay, so now what we want to do is get rid of this. We want to write both sides of the proof. So we're going to list the statement and the reason. So there's another case. I can see that K is in between J and L. So I can say that JK plus KL equals JL by the segment addition postulate. Okay. Well, JK, up here it says that JK is 2x minus 5, so I'm going to substitute that in place of JK. KL is 2x, so I'm going to substitute that in place of KL. JL is 75. I'm substituting measures in for symbols. Now I'm going to start solving. So on this side I'm going to combine my like terms. I have a total of 4x minus 5 equal to 75. This is just a simplification. I'm going to add 5 to both sides. I can do that because the addition property of equality tells me I can do that. I divide both sides by 4. I can do that because the division property of equality. Okay, now unlike the other ones, I'm not done. I know what x is, but they're asking me to find the length of JK. Okay, JK equals 2x minus 5. But I know what x is, so I'm going to write 2 times 20 minus 5. I'm allowed to put 20 in place of x because I'm substituting. Substitution. There we go. And then I'm just going to simplify, so JK is really equal to 75. I'm simplifying. Okay, let's do another one. Okay. Now, up in the givens, it doesn't say anywhere that these are collinear points, so I don't want to make an assumption that they are. So I'm going to make sure that I would set them up as non-collinear points. It might turn out that they end up being collinear, but for my picture, unless I'm given that, I don't want to make that assumption. I've got this. They tell me that LK is 5. They tell me that JK is 5, and they tell me that JK is congruent to JL. This is all given information. Well, if two things equal the same thing, like LK and JK do, they both equal 5, that means they equal each other. And that comes from our transitive property. Okay. Anytime I can follow a path, okay, LK goes to 5. 5 is the same as 5 over here. 5 takes me to JK. If I go from my start point to my end point and cut out the middleman, that's the transitive property. Okay, I'm cutting out the 5 and just putting these equal to each other. If I know they're equal, then I also know that they are congruent. Okay? If equal means congruent, because that's the definition of congruent. I look here, I'm trying to show that LK is congruent to JL. Well, I know LK goes to JK. JK is the same as JK up here. JK goes to JL. So I'm going to cut out the middleman again and just put LK to JL by transitive again. Transitive is going to come up very, very often. Okay, one more here. First I'm going to draw a picture. I'm going to use the given information to help me draw a picture. Okay, X is the midpoint of MN. MN, X is directly in the middle. MX, which is here, is the same as RX. So I need to replicate this distance somewhere. Okay, it doesn't have to be exact, but I know that it's going to have to include X and be about that far away. So I could put it anywhere. I could put R, here, or here, or here, or here. Anywhere that's about the same distance away from X as M is. But I can't put it on M or N. So maybe I'm going to choose to put R down here. Okay, and those are equal, so I'm going to mark my picture like that. I'm going to put my given information. X is the midpoint of MN. MX equals RX. That's all given. Somewhere I need to get down at the bottom, I need to say that XN is the same as RX. So it might help if I could start talking about XN. I already know something about RX. I don't know anything about XN. So I'm going to look at my given information and try to figure out what I can say about XN. Well, I know X is my midpoint. Okay, midpoint means it's in the exact middle of this segment. So that means that this has to be the same as this. So I'm going to say that. MX equals XN, because that's the definition of a midpoint. Now if you can see, I've got a trail that I can follow. Okay, XN goes to MX. MX takes me to RX. Therefore XN equals RX by transitive. Okay, so there's a lot of good examples of some proofs. We're going to get into angle proofs next. So I'll put a video up of a bunch of angle proofs that you can do. These are mostly segment proofs. You had some angles kind of in there, but we're going to start incorporating more of our vocab from angles. So complementary angles, supplementary angles, vertical angles, things like that are going to be in our homework for the angle proof.